In this video, I'm going to solve another example of magnetically coupled circuit with the dot convention. So here he's asking about find the current passing through the capacitor. So clearly I can see two loops. Step one, I'm going to do loop analysis. So step one, I'm going to assign each loop current. By the way, this given circuit is already in frequency domain, so I don't need to convert this into frequency domain. So I1 and I2, there are two currents. Now loop 1, apply KVL. When I apply KVL in loop 1, according to my current direction, I'm going to assign positive and negative sign for the each passive element. Active element is definitely have positive and negative sign. Usually for the source, we always take top one as positive, bottom one as negative. Now the current is going to go or enter the negative terminal at the source, so I'm going to take that as a negative when I'm applying KVL. So minus 100 at an angle of 60 plus 5I1 plus J2 I1 plus J6 I1 minus I2. This is what we learned so far in circuits 1. But here we have the dot convention. That means there is a mutual inductance between those two coils. Now, because of the current flowing in this coil, in the J6 ohms, there is an induced EMF here. Okay, is this current is entering the dot or leaving the dot? So the current, what is the current flowing here? I1 minus I2. Okay, I1 minus I2 is leaving the dot. That means the dot is at the end of the inductor, so current is leaving the dot. So the dot terminal must be negative. Okay, if current is entering the dot, then dotted terminal is going to be positive. So I wrote it down here. I'm repeating. If current is entering the dot, then the dotted terminal of the other coil is positive. If current is leaving the dot, then the dotted terminal of the other coil is negative. So here the current is leaving the dot, so the dotted terminal of the other coil is negative. So let me take that as E1. So am I going to write E1 as positive or negative? So if you look at here, the voltage here has a positive, but E1 has negative. Both are opposite directions, so or opposite signs. I'm going to take that as negative E1. Now when it comes here, E2, let me choose this as E2. We don't know the sign yet, so let me choose this as E2. Current here is entering the dot, so the dotted terminal must be positive, so plus and minus. So this is, the bottom one is going to be positive, top one is going to be negative. So this is going to be same way, these two are in the opposite sign, so minus E2 equal to 0. Now what is E1? E1 is nothing but the voltage across L1 because of current passing through second inductor L2. So E1 equal to, there is a mutual inductance of J3. What is the current passing through this? I1 minus I2. Okay, and E2 equal to, that is because of the current flowing in J2 ohms or L1. I'm going to take this as L1. I'm going to take this as L2. Now E2 is nothing but current passing through the L1. Induced EMF across L2 because of current passing through L1. So which is J3 times, what is the current passing through L1, which is I1. Okay, so that's E1 and E2. So if I rewrite the equation, so I just copied down this equation right here. So minus 100 at an angle of 60, 5I1 plus J2I1 plus J6I1 minus I2 minus J3I1 minus I2 minus J3I1. Okay, so when I simplify this, 5 plus J2I1 minus J3I2. This is my equation 1. Now I'm going to have another equation. At loop 2, apply KVL. Let me write it down here on the top. So loop 2, apply KVL. According to my I2 direction, I'm going to assign positive and negative sign. Positive, negative. Let me remove this E2 to avoid confusion. Okay, I2. I'm going to remove this current direction too, because whenever I am in loop 2, I'm going to follow I2 direction. I'm going to assign according to my I2 direction. This is my positive and negative. Now, regular KVL minus J4 I2 plus J6 I2 minus I1, because that's a current passing through this, I2 minus I1. Okay. Now, because of the current flow here, there is an induced EMF in the second coil. So current I1 here is entering the dot. So the dotted terminal must be positive. So you will end up with the plus and minus E induced EMF. So the self-induced voltage and mutual induced voltage both have the same sign. So you're going to end up adding those two. So plus E. What is E here? E equal to J3 times I1. So I'm going to replace this, J3 times I1 equal to 0. When I simplify this equation, minus J3 I1 plus J2 I2 equal to 0. This is my second equation. My goal is finding I2. Okay, so here I have minus J3 I1 plus J2 I2 equal to 0. Now equation 1 I'm going to multiply with 2. Equation 2 I'm going to multiply with 3, so that I can eliminate I2. Then I can find I1. So 5 times 2, which is 10, plus J4 I1 minus J6 I2 equal to 200 at an angle of 60 degrees, minus J9 I1 plus J6 I2 equal to 0. Okay, I'm going to add these two. When I add them, it's going to be 10 minus J5 I1 equal to 200 at an angle of 60. Now my I1 equal to 200 at an angle of 60 divided by 100 minus J5. So convert that 100 minus J5 into polar format. My apology, this is 10 minus J5. So here, after solving these two, I end up with I1 equal to 17 point, these two equations. After solving these two equations, I end up with I1 equal to 17.88 at an angle of 86.56. Now I substituted this value in equation 2. Equation 2 is right there. Okay, so minus J3 I1 plus J2 I2 equal to 0. So when I move plus J2 I2 other side, I will end up with cancelling minus J both ends. So 2I2 equal to 3I1, I2 equal to 3 by 2 I1. So which is 1.5 I1. When I substitute I1 value here, I end up with 26.83 at an angle of 86.56. This is our I2, current I2. Okay, I will solve more examples in the next video. Please see how I'm writing this E1 and E2 in the equations. The mutual, the induced EMF because of the mutual inductance. Okay, if you have more questions, please see me in my office hours or ask me after the quiz and the next class. Thank you.